Okay guys, welcome to the 12th and what may be one of the longest video for our revision, interference. So here you can see I've written out the learning objectives for interference. There are 5 things that you need to concern yourself with. Account for the formation of maxima and minima when two waves interfere. Understand what is a coherent source of light. Describe Young's double slit experiment. Apply Young's double slit experiment formula, S equals lambda big D over little d, and account for maxima and minima in terms of path difference. So let's begin. We're going to look at these two things right away. So account for the formation of maxima and minima when two waves interfere. So the first thing that we're going to look at is we usually look at two point sources that are in phase. Oh, that's not a very good color. Let's use something darker, purple. In phase with each other. So in phase means they are both starting at the same time, stopping at the same time, and they touch down at exactly the same time for a wave being generated. Or another way to think about that is you can think about two sine curves that are exactly the same. So they are producing two waves that are exactly identical to each other, as you can see. So S1 is producing a wave like that at the same time that S2 produces a wave like that. So this is saying that they're, this is actually getting into coherence, but for them to be in phase, it means they're both starting, let's say at the maximum amplitude at the same time. What is out of phase would be if point number 2, let's say, started off in the middle, so acting a little bit like a, so here we have a cosine, and here we have a sine curve. So this is out of phase by a quarter of, sorry, that's half. It is half off and a quarter of a period off is what I was trying to say. So a quarter of a period off, okay? So those are the same things. Okay, so that's what we mean by in phase. If you really want to go that far, we could do another one that is completely opposite to this. Okay, so this would cause it to be, this is actually 2 pi, sorry, a full pi out of phase now. So it's actually starting down here, right? Okay, and so we're shifting that down. Okay, so this is also out of phase. There's a third one, but I think you guys get the idea. If you don't, let me know. I'll do a follow-up video just about what it means to be in phase and out of phase. Okay, so all of that is just to talk about the formation of maxima and minima when two waves interfere. So it is important that we generally talk about things that are in phase with each other. So if we look at this diagram, what we're seeing here is that when the waves are, when you see the crests meet, so let's say along this green line, okay? Each time you see those dots, that is a sign of constructive interference. And remember that destructive interference causes the wave to go back to equilibrium, go back to an equilibrium position. Okay, so there's 2 types of constructive interference. There is a double crest, so something that looks like a double crest, which is a crest on top of a crest. Okay, and we saw what this looks like. Sorry, let me just, so crest on top of a crest, and that creates something that looks like that. Okay, we can also have a double trough. so a double trough would be, again, two of these guys. And so the result is this part in purple. Okay, and that's actually what we have here. The double dotted lines, let's say right here, that's a double, where two dotted lines meet, that's a double trough. Okay, so that's this type of constructive interference. Okay, and we have two solid lines, that's a double crest, which is also another form of constructive interference. Double crest and double trough. Okay, let's wipe that out just to clear things up. Okay, let's see, double crest, double trough. So that's the formation of maximas. Whoops, I'm on erasing. So that's the formation of maximas. And the formation of minimas, or destructive interference, is on our nodal lines. So I'm going to use a different color. Let's use red here for destruction. So destruction happens when exactly a crest and a trough meet. So we have the combination of a crest and a trough, and the result is a flat line, or what we call the equilibrium position, as if it was not disturbed. Okay, so each time it's a different crest and trough from the other point source, but that's essentially what's going on there. Okay, so we've talked about this first point right here, and while we're on that, let's also talk about the path difference. This was actually a little bit covered earlier already. During points of destructive interference, the wavelength difference. So the wavelength, if we had two waves together, so let's, I'm going to do this in a more linear fashion. So if we have, let's say, a wave from S1, it is something like that. And we have a wave from S2. And what we're saying is that we're going to try to combine these two guys together. Okay, and what's happening is this is missing any multiple of half a wavelength. Okay, so when it's missing half a wavelength, so remember, a full wavelength is, this is one full wavelength, okay? That's one full wavelength, okay? And so therefore, this is half a wavelength. So when the difference, when these two waves merge together, and so it actually looks something more like, I'm going to try to do it on here. So we're going to go like this, and something like that, okay? And then, so that's one, that's two full wavelengths. And this one here might have, so that's one and a half. One, and this is a half. How do you draw two sideways? Like that? Okay, I guess we could write it just straight up and down. I'm going to use a different color. That's not very visible. So that's one from there to there, and from there to there, that part is a half. Actually, let me use a different color to highlight the half so it doesn't blend in. So that right there is half, okay? Whereas we have one there, and let's use orange. We have another one there. So in total, there are actually two here, and in total there is 1.5 there. Okay, so during that point we have destructive interference. Okay, and Let's get rid of all of that. It might be faster if I erased it. The other case is any multiples where, so it could actually be a full, as long as it's a full integer. So that's one wavelength, and this is 1 and 2 wavelengths. So as long as it's a perfect multiple, this will also form constructive interference. Okay, I think constructive interference is probably a lot easier to see and understand. So we have 1 full wavelength here, we have 2 full wavelengths there. Okay, so that's perfect multiples, constructive interference results. Okay, so we've just covered the first 2 pieces there, and let's get into the next stuff. Understand what is a coherent source of light, Young's double slit experiment. Okay, actually, let's stop that video there because that's just so much information. We'll see you guys in the follow-up video.